CryoSat, icebergs in Greenlandic. A well-chosen name for this town, the third largest of Greenland, located north of the Arctic Circle. Along its coast, a multitude of icebergs are drifting. CryoSat is next to a huge glacier, the source of these gigantic pieces of ice. This glacier has been in retreat for many years. For the European Space Agency here, all the elements are present to understand climate changes, and in particular, how the ice coverage of our planet is evolving.
You have here many ingredients of what we do and why we do it. You see out here floating sea ice, icebergs carving a bit around the corner. There starts the ice shield of Greenland, a 3,000 meter thick ice cap, and all this plays a very crucial role in our climate system. And the different parameters of the climate systems, it is what we investigate with our Explorer missions.
Climate change is a global issue, and to comprehend it, a global view is needed that can only be given by satellites. Currently, ESA has 5 satellites observing the Earth, giving invaluable data on several aspects, from gravity to ocean circulation, soil moisture to ocean salinity. Among these so-called Earth Explorer missions, CryoSat is measuring the ice thickness with an accuracy down to 1 centimeter. All these satellites are giving facts, data that cannot be questioned like a model can.
We don't speak about models when we speak about our Earth observation data from satellites. We just describe what we see. And as a matter of fact, we see that the sea ice is retreating very much. And in the last year, since we look at the sea ice, we had almost every year a record low of sea ice extent in the summer in the Arctic. So this is a clear indication that the environment is changing here, and very fast.
On the Greenland ice cap, scientists have been able to make detailed measurements of snow and ice properties, required to validate data from CryoSat. The different types of ice and the nature of the snow have been analyzed, and ESA's ice mission is now able to provide key answers to questions such as how fast the Greenland ice cap is melting and how this will contribute to global sea level.
We're here just about on the equilibrium line of the Greenland ice sheet, so just about the point where as much snow arrives in winter as melts out in summer. And the last 20 years here at this location, the melt has increased year on year, so much so in fact that next year they'll probably have to move the camp to take out this climatological change. So this is exactly what we're trying to measure with CryoSat. Of course, here at the camp you can do this very locally. You can do it in the region around and get some very accurate measurements just in the locality. The task of CryoSat then is to extend those measurements over the entire ice sheet.
From its position in space, and in fact orbiting closer to the poles than any other satellite, CryoSat has a unique point of view, and after this ground validation campaign, ESA can now really give the accurate data needed to understand the relationship between ice and climate change.
In the debate in the last few years, I must say, has revolved around some rather small details. If one looks at the broader picture, climate change is here and it's with us. I think the question today is much more seriously focused on regional change and what's happening in parts of the world. And satellites like CryoSat will continue to be vital for that kind of, to answer that kind of question.
And with CryoSat measurements combined with data from the other Earth Explorer missions, ESA can indeed offer the most complete knowledge about the health status of our planet.